ShellBytes here. Today we're going to be looking at advanced logic gates. Over here we have the full adder. You may recognize part of this from before. This part is actually an XOR gate, and so is this part. There's a bit in the middle that's just some redstone wiring that's not too complex. What it basically does is it combines two XOR gates together so that it can add up two binary values with a carry in and a carry out. So as an example, if I input 1, the output over there is a 1. If I input 1 and 1, then obviously the output is 0, but with a carry of 1. Let's say this carry bit was put into the next adder, because these are tileable this direction. So if I push this lever, it simulates the adder to the left having a carry bit. And this adds 1 to this using the extra XOR gate that was added. So if I add another 1 to it, then you can see that turns off and this one turns on, showing that we're going to carry again onto the next bit. If I do that, then this bit is also going to be on. So it's like standard decimal math, except in binary. Just column addition, but slightly different. Over here we have the RS NOR latch. What this allows us to do is to store a value of memory into some redstone. It basically works using two NOT gates sort of surrounded by each other, and when you power one of them, it toggles the state of the circuit. So if I was to carry on pressing this one, it would keep on going to this side. If I was to carry on pressing this one, the signal would stay on this side. And this is really essential for building things because we need memory in our computer. So this is going to be 100% essential. Over here we actually see something that uses an RS NOR, although you might not be able to see it at first. It uses this redstone torch here that loops round the back and above here. So this is actually a D flip-flop. The way this works is whatever signal you pass in will do nothing until you hit this button. This button is called the set function, and it will choose whatever value you've put in here and it will put it into this RS NOR. So if I press that, then you'll see the output is now on. If I was to disable this and press set, the output is now off. I can toggle this as much as I like and it won't do anything until I press set. So that is very useful for RAM, is what we're going to be using it for actually. So obviously in RAM we're going to need it to set and to clear and all of that, and D flip-flop can do all of that for us just fine. Finally, onto the big one. It looks giant, it's not actually that complicated when you look at it. You might see this in other places rather than redstone computers. This is a T flip-flop or a toggle switch. So when I press this button, I'm just going to disconnect this wire for testing purposes. When I do this, the piston is going to toggle locations. What this means is that I can send a signal through this block. And what that means is that when the block is on the right side and on the right side only, I'm going to have a redstone repeater channel that into this output. So I'm just going to disable that and put the wire back. We can see if we tile this across and take the output and lead it into the toggle of the next one, it works as a binary counter. So if I press it once, we can read the binary value 0001, which means 1. If I press it again, it will actually go on to the next one and it will become 0010, which of course means 2. And it will carry on going. And we don't need all of the complex logic for addition circuits. So you can obviously carry on going, you can carry on tiling this for however much you want. And of course, it is a ripple carry. So if you see here, this will turn black, then this one, then finally that will turn white when I press this switch. It is ripple carry, so there is that slight drawback, but really, there's not much to be lost with that. Thanks for watching. I'll see you in my next video where we start to build an ALU.